Hi guys, and welcome to another chemistry video lesson, National 4-5 Chemistry. We're going to have another look at some hydrocarbons, and this time we're going to focus on a particular family called the alkanes. You might remember talking about the alkanes towards the end of S3. We're going to look at them in a lot more detail now. Your learning intention for the end of this lesson would be to start remembering the names of the first 8 members of the alkane family. Now that won't mean much to you just now, but hopefully it will after this short video. Hopefully you will also start to have an understanding of what we mean by a homologous series. That won't mean anything to you just now either, but again, after this short video, you'll start to have an understanding of that. Okay, let's crack on then. First of all, a little bit of revision from what we've done previously. You can see in the picture on the left, you've got some oil, some crude oil. As we know, crude oil is a fossil fuel, and crude oil is a mixture of lots of different hydrocarbons. Because it's got a mixture of lots of different hydrocarbons, it's not very useful as a fuel on its own. However, those individual hydrocarbons that are in the crude oil, if we can separate them out, are very useful. And we do use a technique called fractional distillation to do that. And we'll talk about that in another video. Although you may remember that we talked a bit about it in S3. So we are going over quite a lot of material that you may have covered in S3. This is just to cement it before moving on to the more difficult stuff as well. Okay. First question though, let's see if we can remember. Let's pause the video and try and answer, what is a hydrocarbon? See if we can get this right. Okay, hopefully you've paused the video and you've had a go at that question. Well, hydrocarbon, the clue's in the name. A hydrocarbon is a compound which contains only the elements hydrogen and carbon. Okay, the clue's in the name, hydrocarbon. It's important that we say only the elements hydrogen and carbon. If you don't say only, then that indicates that yes, it contains hydrogen and carbon, but it may contain other things. A hydrocarbon can contain anything else other than hydrogen and carbon. Okay, brilliant. I hope you got that. Let's move on. Now, we're going to talk about one particular family of hydrocarbons, as I've said, and that family of hydrocarbons is the alkanes. And that's one of the most useful types of hydrocarbon. Each one is slightly different, but they have a few things in common. They have similar chemical properties, similar physical properties. Now, what does that actually mean? Well, similar chemical properties mean they behave similarly when you burn them, for example, or when you do some tests on them, or they behave similarly in terms of how easily they combust, or what they look like when they're poured. Their physical properties, well, that's essentially what they look like. Okay, are they liquid? Are they gas? And the truth is they are all three. But they behave in a very similar way. And they have a general formula. What that means is that there's a formula that can be written for all of them. And we'll talk about that in the next video. But what I want you to remember is that this family is what we call a homologous series. Now, there are other homologous series out there that we will be talking about, but to identify a homologous series, something can be described as being a homologous series if it has similar chemical properties, similar physical properties, and you can write a general formula for them. So that's very important. And we'll go on and talk about each of those different things later on in each of the videos when we talk about the hydrocarbons. But the important thing is that you remember that that is a homologous series. So we're going to talk about the homologous series called the alkanes. So we're leaving that family, the idea of a family behind, and we're saying, right, it's a homologous series. We're chemists now. Homologous series. So let's have a look at them in more detail, if I can get the slide to move forward. Having some difficulty. There we go. Now, we're going to carry this family analogy moving forward while we're talking about the naming just now, because the alkanes are hydrocarbons. That means that they've only made up of two types of element, carbon and hydrogen. Okay, and we talked about that about a minute ago. The alkanes, if they are a family, okay, we know that means they're a homologous series, but if we keep this idea of a family going just now, the alkanes are a family, they have the same surname. And the alkane's surname is ANE. So every single alkane has the same ending in its name, ANE. Just the same as every member of your immediate family has the same surname. What differentiates you is your first name. You will have a different first name to your brothers or sisters or mum or dad in most cases. The alkanes are no different. What differentiates them, however, is the number of carbons that make it up. Okay, we know that there's only carbon and hydrogen can be present. So what we do is we use the number of carbons to tell us what alkane it is, and then we give it a particular name. So what I've done here is I've got a table, and I've said, well, we're going to look at the first 8 alkanes, 1 to 8 in terms of number of carbons. Depending on the number of carbons depends on the first part of the name. They will all have the same surname, but their first name is here, depending on the number of carbons. So if you've got 1 carbon in your alkane, the name is meth, which means that when you put the first name and the surname together, you end up with the whole name of the alkane being methane. Now, unlike us, they don't separate the first name and surname. It's all the one thing. So let's look. If you've got 2 carbons and you're an alkane, then your first name is eth. And of course you're an alkane, so your surname must be ANE. And the same goes for each of these. So pause the video just now and try and fill in each of these. You will find a table in your notes which has all of this in it. Try and fill in all the names of the alkanes. Pause the video. I'll go ahead and do that just now. So you've got propane, butane, pentane, hexane, heptane, and octane. Hopefully you got that all by yourself. If you didn't, then go back and listen to the video, just that last couple of minutes, and see where I'm getting that from. And if you're still struggling, then let me know. Okay, so hopefully you're seeing where those names are coming from. For you, what you need to be able to do is remember the first 8. Okay, so you need to remember that the alkanes all have an ending of ANE, and that if there is 1 carbon in the name, then it's meth. If it's 2, then it's eth. 3, then prop, etc. Okay, you need to remember the first 8. Now, there are different ways of doing that. One way is to try and create a word or a sentence that begins, each word in that sentence begins with the letter M, E, P, B, P, HHO. And you can make that up. It doesn't matter what it is. And there's an example of that in your notes as well. So have a little look. You can use the one in your notes, or you can try and make one up yourself. I find trying to make one up yourself is a lot better than using one that I've given you. But the important thing is that you need to be able to remember these, okay? Good. Have a go at some of these questions. Pause the video. There are 3 questions. All it's asking you, it's going to give you some information on the number of carbons. What's the name of the hydrocarbon? What's the name of the alkane? Okay. Pause the video and give it a go. Okay, the first one, what is the name of the alkane with 3 carbons? Well, hopefully you should be remembering now that 3 carbons, well, it's meth, eth, prop. So that would be prop, and because it's an alkane, it's propane. How many carbons does pentane have? Well, meth, eth, prop, but, pent. Well, that must be 5. Number 3, an alkane which has 8 carbons. What is my name? Meth, eth, prop, but, pent, hex, hept, oct. And it's an alkane, so it's ANE on the end, is octane. Okay, there will be some questions to try in your class notebook. Go back and have a look at the tasks and see what the next task is after watching this video. Okay, thanks very much guys.